Hello and welcome to my channel. I am Vincent Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and if you're not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we are going to look at how to prove that the inverse of a function exists and also find the derivative of an inverse function at a given point. Join me as we go through this simple question. This question was sent to me by Mustafa Muhammad from University of Ghana, Legon. Mustafa, thank you for this question. Now, show that f of x equal to x cubed minus x squared plus 1 for x greater than 2 out of 3 has an inverse. If g is the inverse of f, find g prime of 1. Now, let's find the derivative of f of x. Why are we finding the derivative of f of x? Because we want to show whether f of x is increasing or decreasing. So f prime of x equals, if you differentiate x cubed, you get 3x squared. If you differentiate minus x squared, you get minus 2x. If you differentiate a constant, it is 0. Now, for all the values of x greater than 2 out of 3, what do I mean by that? Let's take a number greater than 2 out of 3. 2 out of 3 in this one is 0.6667. So 1 is greater than 2 out of 3. 2 is greater than 2 out of 3. 3 is greater than 2 out of 3. 0.7 is greater than 2 out of 3. 0.7888 is greater than 2 out of 3. So any value that we pick, just put it here and check. So let's check f prime of 1. This will give us 3 times 1 squared minus 2 times 1. And that will give us 1. If we check f prime of 2, that is 3 times 2 squared minus 2 times 1. That will give us 12 minus, it's 2 times 2. 12 minus 4, and that is 8. This is greater than 1, greater than 0. This is also greater than 0. So, we have seen that for all values of x greater than 2 out of 3, f prime of x is greater than 0. Correct. So let me clean this part. So we've seen that f prime of x, which is equal to 3x squared minus 2x, is greater than 0 for all x greater than 2 out of 3. Hence, we can say that f of x is increasing on the interval 2 out of 3 up to infinity, and hence it is 1 to 1. Therefore, f inverse of x exists. Wow, why have I written 2 on 3 up to infinity? 2 on 3 is not among because of the open bracket. That is for values of x greater than 2 out of 3 up to infinity. F prime of x is always greater than 0. Hence, f of x is increasing on this interval. And hence, the inverse of the function exists. Now, we are saying that g is the inverse of f of x. So it means that if I let f of x is equal to 1, why am I using this 1? It is because of this 1. Wow. Then it follows that g of 1 is equal to x. Since g is the inverse of f, if you are confused, it is the same as writing f of x equal to 1 implies that f inverse of 1 is equal to x. But here you are saying that g is representing the f inverse. That's why I've used g here. So let's move on. So you have f of x equal to 1 implies that this is our f of x. X cubed minus x squared plus 1 is equal to 1. And this gives x cubed minus x squared equal to 0. If we bring this 1 here, very simple, right? So I have x squared into bracket x minus 1 is equal to 0. I have x equal to 0 and x equal to 1. But x equal to 0 is outside this interval. It is only x equal to 1 that we can find within this interval. So now, this implies that our x is equal to 1. Very simple as that. Wow. So, we have our f of 1 equal to 1 and g of 1 equal to 1. And we know from the formula that g prime of x is equal to 1 divided by f prime of g of x. So here, g prime of 1 is the same as 1 divided by f prime of g of 1, which is equal to 1 divided by f prime of g of 1 is 1. Now what's our f prime? We found it here. Our f prime is 3x² minus 2x. So let's find f prime of 1 and see. F prime of 1 is now 3 times 1 squared minus 2 times 1. And that will give us 1. So this will give us 1 divided by 1, which is equal to 1. So our g prime of 1 is equal to 1. Thank you for watching. Please like, share, subscribe, and leave your comments. Bye-bye.